guys, welcome to my YouTube channel Cadence Virtuoso. So from today we will be looking into how to design analog layout. Okay. So as you all are know, VLSI design is going to be a trending technology in upcoming days. So for that, if even a circuit is designed, for that there has to be layout, there has to be physical design layout engineer. So ma many things that comes into the picture if a chip has to be fabricated. So we will be looking at the technology GPDK90nm. So on this technology we will be working on this video. So if you are following any analog layout course, whatever to do it, and want to do analog layout for from the scratch, so do follow this course. So without wasting much time, we will get into the video. So for today, we will be looking into how to do the layout design for the basic components like PMOS, NMOS. As you all know, what is PMOS, what is NMOS. P is of P type, okay? N is for N type. So without wasting much time, get into the video. Once you launch your Virtuoso tool, you will be facing this window. In this window, you will have to just need to create your library. Just go to File, New, press on Library. So I am going to make it for YouTube. Okay, and technology file attached to the existing technology library. Just press OK, and here you have to select the technology library as GPDK90. Okay, once it is design library YouTube successfully attached to the technology library GPDK90, it means our library is created. Next, we have to do the cell. Okay, for that go to view, click on cell view. Here we have to select your library, which library we have created. It is YouTube. Let's make it cell as PMOS Y. Okay, PMOS is a component that we are going to do the analog layout, and Y is for our reference. It is Y for YouTube. Okay, and view should be schematic. Type should be schematic. Okay, when we want to do the layout, we have to choose your type. Type as layout, as you can see. Okay, next application, open with schematic L only and press OK. Okay, here we have got the window, that is schematic window. Once you get onto over here, you will be seeing some of the dots. That is a reference point. We'll be following. We'll be looking into the same points in our layout design also. Okay, once you click over here, press I, go to browse. Okay, already I have selected, but I will show you once again how this works. Go to GPDK90, just click over here, go to MOSFET. Today we are going to design the PMOS. PMOS. There are various type of PMOS cells already defined into this library. Go over here, symbol, click on symbol, okay, and just close. So as you can see here, there are many options. Model name is, this is a PMOS one from GPDK90nm library. Multipliers one, we'll be looking into this all the things. What is multiplier? The length we are going to do, for which we are going to do our layout design is 100 nanometer. Total width will be 120 nanometer. Finger width, fingers concept, all of these we are going to look into further videos. This is all about threshold. So once you do this, just hide, okay, and you can see over here your PMOS symbol. Just press anywhere and just escape. Once you get over here, press F, you will be seeing this symbol. Okay, for this we have to do our layout design. But before doing the layout design, we have to create some pins instantly. So go over here, just give the pin names as VDD, VSS, and E. E will be our input, and direction should be of input output. User schematic, okay, signal type signal, okay. side. This is your VDD, this is VSS, sorry, just press escape, done, press F8, okay. Just need to wire this from this terminal to VDD and our drain terminal to VSS. As you all are know, this arrow symbol, as you can see, this is acting as a source for our PMOS, and this will be our drain automatically, and gate terminal will be connected to our input A, okay. To wire this, press W, you'll be seeing cursor in different mode, and just click over here and stretch till VDD center point, okay. From this VSS to here, input, done. Right now, we have connected our three terminals, that is source, gate and drain. Next, we have to connect our body terminal to source. Whatever your design you are going to do in schematic, your body has to be connected to the source. Let it be of NMOS or PMOS, okay. So this is acting as a source. So we have to connect this body to source, okay. So it is connected right now. So escape and check and save. Right now there is no any error. As you can see, if I delete this wire and escape and press check and save, you'll be seeing there is one error, two warnings. It means you can see errors over here. See, A is floating, input output. Okay, this is an error that we have been facing. So it has to be connected with our terminal. So press W to connect it, or else you can press U also. So it will undo because we have checked and saved, right. So it won't work right now. So we have to redo it again. So press W and connect. Right now, just check and save. So as you can see, our schematic is passed without any error. So after that, just go to launch. We have to do the layout. Go to layout Excel. Layout will be create new. Configuration will be automatic. Okay. Press OK. Once you press OK, it will be asking you in which library you are going to keep your layout. It should be up to you too. And save will be PMOS by the same name we are going to save our layout also. V will be layout, type will be layout. Next go to OK. Okay. So right now our layout window is open. So this is our layout window. As you can see, this is our origin, these are the axis, this is the x axis, this is y axis. So firstly, first 1 week we just try to explore the what are the things are there into the layout. I mean to say explore what are the options it is providing you. There are many options as you can see here. This file, move, copy, how to copy the object, or how to stage the object, how to delete. So all things we will be looking into if you ask, if you I get any response in this video. Also, if you want to learn, just put your comments in the comment section. I would happy to help you out. So before doing any kind of layout, just get into the layout window and press C. Once you press your from your keyboard E, you'll be finding this will be pop up. You'll be seeing that this is a main important thing we have to keep into the mind. X snap spacing and Y snap spacing, it should be of multiple of 0.005. Just keep that in mind. It should be multiple of 0.005. Right now it is a multiple of 0.005, right? But we will be making it 0.05. Why? Because if you don't do this, you'll be getting their off-grid error. Okay. So your design will not be set what actually it is supposed to. I mean, this tool will not pass your design. Okay. And if you want to keep the minor spacing, you can keep it as 0.001. Again, major spacing will be 0.001. We will look into what actually it is. Okay. So press OK. So right now you can see dots are there. If you want to measure the distance between them, press scale. From two dots, you will be seeing press K over here. Okay, it means, as you can see, I am able to just measure the distance in between the 0 to 0.005. It means this is our grid. Okay, this grid has to be followed by our layout. You can see directly I am jumping to 0.0. Okay, so this is the reason why. So because we have done our X snapping and Y snapping. Okay, just a scale. Hope you got the what is significance of that X snapping and Y snapping over here. It is 0.001, and this is what you are not supposed to change at all. Okay, whatever the foundry is given, whenever you used to do the layout, the foundry will be specifying you what should be the X snapping, what should be the Y snapping. On the basis of that, you are supposed to do our layout design. Okay, and this is for your reference. You can do it because this will help you out to design your at what level you are supposed to get into the layout design. Okay, I mean to say, if you want to select any edge or any components, till what extent you can select that. I mean to say, if there are two edges which are close to each other and their spacing is too small and you want to select both of them, so it will help you out. Okay, so we'll be exploring the many things in this video. If you want to really yet about how analog layout design is going to be done, just stay tuned with us. We'll be help you out. Okay. Next, press OK. So press F. Okay. So okay, done. Next thing we got over here. I mean we have done something here. That's why we were not getting origin. Okay. Just press F. And yeah, it is only. Right now we have got our origin. Next thing you are supposed to do our layout. Okay. Now firstly we are going to do our layout design for our PMOS. Okay. Hope all of you are known the fabrication process of uh, any IC. Okay. So firstly we used to take we used to take our OD oxide layer. Okay. OD is known for oxide layer. Oxide layer will help you out to isolate your overall this part with your water substrate you have been using. For by default, we have been using P substrate at the background. Whatever the black screen you have been seeing, this is a P substrate. In that, we are supposed to do our layout. Okay, so this will go OD. Next, there will be gate formation, it, and this has to be done by using etching. Okay, and this is our source. Okay, this will be our tray. Okay, this is the actual layout we are going to look into. Okay. So this is source, this is drain, this is a gate, this is a OD. So these are the layers we are supposed to form over. This is the top view. If you might have seen your BTEC level also. The front view of the PMOS or NMOS is going to be in this fashion, right? So this will be a bell. Okay. Uh, this is a E plus wave. Okay. Just connect this over here. And this is our gate terminal, this is our source, this is our drain. So this type of structure you might have seen in your BTEC level, but right now we have been looking into it in top view. Okay, we see this. If you see, sorry, if you see the same structure from top view, see the same structure on top view, you'll be seeing that it is a 3D view, okay, and background also you'll be seeing, at the background also you'll be seeing it is extended, okay. This is just top view, this is a face. Actually body we are going to not going to see in our textbook, BTEX textbook. You see this from top view. From here, if you see downside, you'll be seeing your layout will be in this fashion. This is your gate. This is your gate. Okay. This is your source. This is your drain. Okay. In this fashion, you will be seeing your layout, and on the top of it, you will be having a your oxide layer. Okay. This is going to be done during the fabrication process. Just this is all about your layout fabric basic that is required for the layout design of any PMOS or NMOS. Okay. Next, shift key. So this will disappear all the scales. So we'll be doing our layout. Press F. Firstly, we have to take our oxide. You can go over here, search for oxide. In some of the technology, it is shown by UOD, but you can go with the oxide. Okay. Press R. Okay. Click somewhere. Okay. If you get this structure, just click on it, just select, because if you see over here there are many options. This is the right now it is full select. You can see full select. If you click over here, it will be partially selected. It means it is able to select the edges. If I press turn switch it from partial select to full select, it will select your entire things. Okay. Just a scale. Select this, press Q. You will find there are various uh, properties, attributes that you can be changing. So there is layer, left, right. This is what we are not going to look into. But this is height for a woody. This height is main important thing, because height is going to act as our width. Okay, I mean to say, as you can see in basics of layout, the height of your OD will be defined your what should be the width of your MOSFET. Okay, so right now it is what should be width 120 nanometer. So actually this scale used to be micrometer level. Okay, so if you want to convert that 120 nanometer in terms of micrometer, it should be 0.120 micrometer. Okay, and just apply. If you apply over it and okay, as you can see it is 120 0.12. So I measure from this, it is 0.12. So right now our OD width is defined. You can just cut this. Okay, first select this, Control C, sorry, Shift C. It will cut this OD. Shift C is used for chopping any object. Okay. Next thing you are supposed to do our gate. Okay, poly layer. Poly layer help out to the formation of gate. Okay. Next, go to search bar, select over here poly, press R, go to layer, we'll be getting poly over here. The poly, so this is going to act as our length. Okay, what should be the length of our PMOS or NMOS? So right now we are having 100 nanometer as the length. Okay, so go to PMOS over here. It should be of 100 nanometer. In terms of micrometer, it should be 0.1. Right? Press apply. Okay. Sorry, I have done its width. It should be width. Okay. It should be 0.1. Just apply and okay. So right now you got your poly layer and oxide layer. It is of 0.1 and this is of 0.12. It means we have satisfied our parameter. Okay. Select this. Just drop this 60. chopped and fit. It is done right now. Next, we are supposed to do our contacts. Okay, for this, for this, we'll be making it for micrometer level. Sorry guys, we will be making it for micrometer level only because this is not going to support the contacts whatever we have been doing. It won't support that for our nanometer. Okay, because it will fill the entire space. Let's make this width length will be 1 micrometer, and let's make width of 2 micrometer, and press apply and okay, and check and save. If you want to check and save over here, go to our layout window, press F, search for your option, same steps we are supposed to do. Press R, okay, escape, click over here, go to Q, add should be of 2 because this is going to define our width. Okay, and now it is done. Next, you are supposed to do the poly. Press R, go over here, escape, click on it, press Q. Width should be of 1 micrometer because right now we have been working on micrometer level, and what is the scaling, it is going to be in terms of micrometer only, right? So once you done this, you are supposed to do the contact on our oxide layer. Okay, so go over here, you can see contact, press R, it is done. Okay, just click on it and delete. Okay, so you will be seeing their contact. Okay, so we are going to stretch this till here. So select partial, select, press yes, select this turn edge, and just drag your cursor. Be seeing that it is dragged, and in similar way this has to be filled here. So right now we are going to see the DRC using the Assura tool. So before that we are supposed to see what should be the contacts dimension. Okay, press Q. Let's make it 0.1. If you want to see what should be the actual dimensions of your contacts, you have to go from very tiny level. Okay, just move it over here. Smooth. Okay, once you do that, you have to go for run Assura because for DRC purpose we are going to use our Assura run DRC. Here you can see which library, which cell we are going to do run our DRC design rule check. Okay, this is YouTube, PMOS, Y. Everything is set right now. The technology we have been using is GPDK90, and this is a rule file that has been there into the library only. Next the thing, we are supposed to uh, apply. Okay, okay, it's lagging. Okay, this is a progress. Dada, dada, dada. No. This is a progress. Next, you are supposed to do the. Do you want to view the result in the run? Yes. Okay. Also did that. You will be seeing that P substrate stamp error code is an error that our layout has given, but just ignore this for as of now. Go to over here. Here they have given oxide must be covered by an implant. This also you can ignore. We'll be looking into that afterward. Next thing, contact shape must be 0.12 cross 0.12. It means it should be of 0.12 micrometer cross 0.12 micrometer rectangle. Okay, just click on it. You can right click and change the color. You'll be seeing that whatever the errors that we have just highlighted over here, Go to our layout, you will be seeing your error. Okay. Yes. And it's error window. Sorry. All visible. Okay. All visible. So right now you can see over here pink color. It is showing that it has to be 0.12 cross 0.12. Just press on key. It should be of 0.12. Width should be 0.12. Height should be of 0.12. Click on apply. Okay. So right now it is 0.12. If you save and again run the DRC, apply, you'll be seeing that this error will be disappeared from there. Okay, what is the context error we have been seeing 0.12 cross 0.12, it has been disappeared. So as you can see, it is the errors have been listed over here, but you are not supposed to see the your contacts. Okay, contact error. What should be the dimension? Because we have already set it. Next thing you are supposed to see, this is a sequence you are supposed to do any cell layout. Okay, from sketch. Let's move over here. Next thing you are supposed to see what should be the spacing from or what actual gate and your contacts. Okay, right now we are supposed to keep it as close as possible and just save, because we are going to see what should be this space. If you want to see what should be this space also, you just place your contact near to your edge of oxide and poly. This is acting as a plate. Okay, what should be this spacing and this spacing we are going to see over here. Next, save and run our DRC. Just click on apply. Okay, yes. Okay, once you done that, it will show some errors. Okay, so it has given over here contact to plate spacing must be 0.10. Okay, yeah, it is given. It is highlighted by blue color. Okay, it should be 0.1. Okay, it is 0.10. Go over here, select this contact, press A, right click, go to options, user spacing. It should be 0.10. Okay, just hide. And right now you just select the edge, the components you are supposed to move. Okay, just select the edge with what reference you are supposed to move it. It should be with the gate edge. Okay, so as you can see, it is right now the spacing between the gate to contact edge is 0.1. Okay, just escape. Next error is related to what should the spacing from our oxide edge to contact edge. Okay, go to error layout, not equal. Next, what should the oxide to contact enclosure must be? It should be 0.06 micrometer. Go over here, select this, press A, right click, option 0.06. Okay, once you did that, just select this edge with respect to this. Okay, so right now we have placed our contact, but next thing we are supposed to see what should the spacing between this edge to our contact edge. Okay, for that stretch this edge towards the contacts and press F. Okay, right now we are going to see what should the spacing between our oxide edge and the contact edge. Escape, just save and run the DR. Supply. So yes, okay, it's progressing. Yes, okay. Then again they have given your oxide to contact enclosure must be 0.06. So once you click on this, you'll be seeing that highlight. Okay, it should be 0.06. Press A, options. Already it is 0.06. Select this edge with respect to this, it is 0.06. Right now it is set. So these are the steps you are supposed to follow while doing the layout. Okay, right now we are going to see what is the distance between your gate edge to your oxide edge. Last it is 0.28. So in same fashion this is going to replicate on other side too. So right now only we are going to make it 0.28. Okay, press a go to options, make it 0.28, 0.28 height. Okay, select this edge with respect to this with 0.28. Done. Next thing, you are supposed to copy your contacts. Why contacts is going to be made? Because whenever you are supposed to take the connection from any of the terminal, let it be of source or drain, there should be a contact, right? Because without contact you are not supposed to interact with whatever the material that has been inserted into it. If you want to give any supply, you have to give the contact. To contact only you are supposed to connect your outer source with this our PMOS design. Next thing, you are supposed to give the as many as contact possible. Okay, because right now it is one, so we have to copy this same contact for our drain side, source side as well as drain side. Okay, any one of these terminals is going to act as a source or drain as per our voltage. Okay, in layout there is not any definition that your left side should be of source and side should be of drain. Nothing like that. It's up to you how you are going to use this. Next thing, if you press Shift key, the scale is disappeared. Select this contact entirely. Click on C, F3. You will be seeing that there are many options. You can explore this as per your requirement. Go to spacing. So before that, we are going to see what should be the contact to contact spacing. Okay. So I press F3, keep copying. So right now we are going to see what should be the spacing between this edge to this edge. I mean to say what is the spacing between two adjacent contacts. You save and run the DRC and apply and OK. Yes, it is saying that what should the spacing it has to follow. So as you can see, contact to contact spacing must be 0.12 micrometer. So let's make it 0.12. Select this contact, press A, option 0.14, sorry, 0.14. Height, select this edge. Okay. Right now it is 0.14. It means we are supposed to do the contacts arrangement in 0.14 distance. Okay. For that you can click on this contact, click on C, F3, go to array, untick this keep copy, go to array, rows should be let it be 10, the column only one column we wanted, and what is the spacing for x spacing should be 0, y spacing should be 0.14. If you want to explore, you can explore this all things. Okay, how the layout is going to be changed as you change the any one of the parameter. Just apply. Okay, it has created 10 different contacts. Here you can just move this little bit downward. Press here and select this edge, and it will be keep on moving. Okay, come to downside and just align with this. Okay, right now it is fully filled with our contacts. This is an extra contact we have been seeing. You are supposed to delete this because we are going to adjust our contacts, make it full select because it is selecting this outside edge. And now it is selected, cancel it out. Press F. Okay. Right now we are supposed to adjust the same spacing upward as well as downward. Okay. This spacing and whatever spacing you have been looking into, this spacing has to be same. Okay. So let's measure it out. Press K, it is 0.06 and it is 0.26. Okay, escape. If you add the 0.06 and 0.26, 0.32 divided by 2, it should be 0.16. It means the adjacent spacing has to be 0.16. Okay. Select this context, all contexts. Just press on a option, make it 0.16, hide, and select this edge. Done. Okay. Right now, it is symmetrical from upward as well as downward. Okay. Next thing, you are supposed to copy this context, all of these contacts to right side. Press C, F3, because we have to untick this space here, and rows also have to be 1, and keep copying. Done. Then hide. So you are supposed to copy this to the right side. So right now it is done. Escape. So we are supposed to see what is the spacing. The same spacing we have to keep. It is 0.1. The same spacing we are supposed to keep for these contacts also. Press A, option, make it 0.1, hide. Okay. Select this edge. Okay. Right now it is set. So this is all about how to place the contacts on our UV layer. Okay. Next, save. Next thing, we are supposed to just cover this whole thing with our P implant, right? Because, because we have been doing our PMOS design. The PMOS is going to be recite into the N-wave. Next thing, we are supposed to do the N-wave formation also, but right now we're looking into P implant. So go over here, select the P implant, press R, and just draw it. We'll be looking into what's the spacing between our oxide to P implant, and uh, right now only we're doing NVL formation also, because I'll be telling you what is the reason of forming the PMOS into the NVL. Okay, because whatever the black screen you have been seeing, that is a piece substrate. Into the piece substrate, we have our body terminal should be of N type, right? So the NVL will isolate your overall PMOS uh, design with from your whatever substrate, P substrate. Okay, for that NVL is going to be formed. Whenever fabrication goes on, there is to be a P substrate. In that NVL formation is to be done. In that NVL, we are supposed to do our PMOS. Okay, for NMOS, we are going to do directly on P substrate only. Okay, it doesn't matter uh, whether we are going to do anyway, because for NMOS, just your drain and source terminal should be of N type. Done. Next thing, we are going to see what is the spacing between this P implant edge to our oxide. Okay, if you save, check and save. Next thing, you are going to run the DRC again. So these are the steps you are supposed to follow while doing the accurate design. Okay, hopefully you have been enjoying. So right now we have seen there are listed errors. So it is given that P implant to oxide enclosure must be 0.14. We will be highlighting. So it should be 0.14. 1A, calculate 0.14 right now. Okay, like path will select. Shift, let's resolve next error. Over here, given that P implant to gate end enclosure must be 0.18. Okay, it should be P implant to gate end enclosure should be 0.18. So yeah, this edge should be 0.18. Okay, make it 0.18, apply and hide. Select this edge with respect to this should be 0.18. In similar fashion, your downside edge should be of at distance 0.18. Just escape. So right now PMOS error is done. Next thing you are supposed to look into metal to contact enclosure must be 0.5 km. We'll be looking into it afterwards. Once you done over this, just save your design. Right now we are going to see what should the spacing between your anvil edge your OD. Okay, just stretch your anvil till your OD. We'll be looking into what the spacing it has to be followed. Yeah, save and run your DRC again. Apply. Okay. Yes. So it has given that anvil to P plus oxide enclosure must be 0.12. It means from a P plus implant, P plus oxide, I'll be showing you what is the P plus oxide. Okay, let me select. So P plus oxide means common area, right? So P implant and this oxide, P plus from here to here it should be 0.12. Let's make it 0.12. Select the edge with respect to it. It should be 0.12. Similar fashion, we have to do it 0.12. Okay. Yeah, it's done. Next thing, you are supposed to see what should be the spacing between your edge, poly edge to your oxide. Okay, stretch this poly edge with respect to oxide. We'll be looking into it. Just save and run our DRC. Apply. See, as you can see, as we keep on resolving the errors are getting disappeared, right? It means this is a way to approach any layout from scratch. Next thing, poly to P plus enclosure must be 0.18. See over here, poly to P plus enclosure. I meant to say this distance. This distance should be 0.18. Okay, let's make it 0.18. Hide. Let's say, yeah, it's 0.18. In similar fashion, we are supposed to do it the outside of it. Okay? Yeah, it's done. So move this. Sorry, done. Press F, it will magnify your design. Next thing, so the core part, the whatever this overall this has been done. Right now we are supposed to do the VTD VSS. Okay, for that you are supposed to do for VDD for PMOS. We used to do P tap. Okay, P tap for PMOS. For VDD it is going to be P tap. Here VSS it should be again P tap. Okay, here we are going to give our power supply. Done. I mean to say, if you want to do your P substrate connection with our power source, it should be of P plus, right? Then only your latch up problem will reduce. Once you give the P plus implant, it will reduce the resistance to give the supply. So overall, the latch up will be reduced. We will be looking into what is latch up. There are many things that problem arises while a fabrication process. So to reduce that latch up, we are supposed to form a P tap over here. Okay, for that again go to oxide. Oxide will help you out to do the isolation. Okay, click on R, done. Okay, once you done this, and just keep that in your mind that this edge, what are the n-type oxide layer you are going to see, this has to be aligned with the edge of your anvil. Okay, because while doing your abandonment in the sense, many cells are going to be arranged in such a fashion that they are used to be in adjacent to each other. While that time, what happens? Uh, the cells are going to be connected with our other cells. Okay, because n well, whatever you are saying, we will be doing that in further videos if you respond me well. Uh, while doing the abandonment, this has to be connected with the next P cell, because right now I will be showing you. If you copy this, okay, yes. So while doing the abandonment in the cell, you want to do this has to be aligned with the next cell. Okay, so what I wanted to say, hope you got this. Next thing, you are supposed to align this your oxide with your uh, NVL edge. Okay, let's align this spacing, no spacing. Okay, spacing, no spacing. Align this for edge. Done. Do the same fetch, same thing for a next edge also. Just click on A, align. Done. Right now the alignment is done. Next thing, you are supposed to do the contact. I mean it's a metal overlapping. Okay, the oxide on that we are supposed to do the metal overlapping. Just go here, metal one. Okay, click on R. Just overlap this all oxide, P-type oxide with metal. Right now it is overlapped with metal. Next thing we are supposed to give the contact, and this is the only sequence you are supposed to follow while doing any kind of layout from scratch. Okay, go to contact. Already we have done your contact, right? Just copy this. See, make it over here. Escape, and we are supposed to see what should be the spacing between this edge to our contact edge, right? Let's move this little bit closer to this. Escape, and say, sorry, save our design and run our DRC. Okay, okay, yes. Hope you have been enjoying your first layout of so it has thrown some errors. So poly to oxide spacing should be looking into it afterwards. And firstly, we are supposed to say oxide to contact enclosure must be 0.06. Okay, so it will highlight over here. It should be 0.06. Select your contact A. It should be options user spacing 0.06. Height. Select this edge. Put it 0.06. Okay, done. Next thing, you are supposed to copy your contacts. Sorry, it means whatever the spacing we have been looking into over here, the same spacing has to be followed for upside and downside. Okay, for your entire. Just keep that in mind. Make it 0.06. Okay, done. Okay. Now we are supposed to copy your contact for this uh, entire P tab. Sorry, this one C F3. Just keep copying spacing. What should be the spacing between two adjacent? It should be 0.14, right? Right now we are going to set it for x-axis, because x-axis in this way we are supposed to copy our object. Press on apply. Sorry. Let's undo this. Select this object. C F3. Rows should be 1. Column should be let it be 10. Okay. 10. Done and apply. Yeah, we got this. Okay. The extra context you are supposed to delete. Sorry, delete. Done. Okay. Right now we are going to adjust this contact with our edge. What is spacing must be 0.06. Now it is 0.06. Yeah, it is adjusted already. So next thing we are going to give the P implant for this. You see, go to use layer. Because P implant we have already used it. Click on R and we'll see what should be spacing between our P tap outside to our P implant. Okay, let's get. Just save this overall thing. Run your DR. Just apply. Okay. Also apply this. You'll be seeing your error window. Yes, it's lagging. Yeah, got this error window. So it has given N-wave to P plus oxide spacing must be 0.3 micrometer. Go here. Also, it has given that. It is already highlighting. Let's make highlight with different color. Okay. Over here, it has given this should be 0.3 micrometer. So for that, select this entire design and make it 0.3 micrometer. Okay. Sorry. For here we are not going to use P tab. Here for P tab for sorry for PMOS we are going to use N tab. Okay. Or for NMOS we are going to use P tab. So we have to extend this N wave, stretch this N wave towards upside little bit. So you will be looking over here. I am going to say like see this is your N wave. Okay. In this your N tab should be there and here your MOSFET should reside. Okay. In this fashion. Okay. So this is your MOSFET. So this is your whatever rectangle you are seeing. This is your N wave. Sorry. And this is your N tab. Okay. Done. Uh, so in similar fashion we are supposed to do. Okay. For that, just delete this. We'll be looking. Just save this. I think there has to be some spacing from this oxide to our N wave edge. We'll look into it. Just save and run the DRC. Just apply. Also apply this. Yes. It has to be changed again. Okay. They have given here. Oxide must be quality oxide spacing must be 0.1 micrometer. Quality oxide spacing. It should be 0.1 micrometer. Select the center edge A, make it 0.1. Okay. 0.1 micrometer it is done. And next error they have plotted over here. Oxide must be covered by N implant or P implant. Okay. So right now your oxide must be covered. The error is directed towards this. okay. So the layout design. So diagonal oxide must be covered by the PM plant or NM plant. Okay. So for a PMOS, it has to be NM plant. Okay. One check is used there. NM plant. Deploy. Okay. Done. Click on R. It has to be covered by NM plant. Once you've done that, you will be seeing what's the spacing between your oxide layer to your NM plant. Okay. Save and run the DRC again. Click on OK. Yes. So next error they have given that n to n plus enclosure must be 0.12. We look into it. 0.12. Make it power equal. Yeah, they are given that n to n plus enclosure must be 0.12. It means your n has to be 0.12 apart from your n plus. Okay, stretch your n. It will be equal. Stretch our n little bit outside. Make it 0.12 with respect to our NM plan. And already they have given what should be the spacing from your oxide to NM pad. Okay, escape. It should be 0.02. N implant to oxide enclosure must be 0.02. Okay, means this enclosure should be 0.02 into a option. Make it 0.02 height. Okay, from all the sides. Done. Okay, and next thing they have given that its n to n plus oxide inclusion must be 0.12. Saving this and running the DRC again, we'll be looking into it because we have altered it prior. And then DRC progress. Okay. Yes. Yeah. Should be 0.12. Yeah. Whatever spacing we have been seeing, it should be of 0.12 options. Make it 0.12 height. From all the side we are supposed to do it. Yeah, done. Right now we have done with our DRC of our ion tap. Okay. Next thing you are supposed to do the P tab. Okay, because VSS connection. As you can see in your schematic, is a VSS VDD. For VDD we have done. Next thing we are supposed to do it for your VSS. Okay, go to PMOS. You are supposed to copy the same thing. Okay, except your NM part. The same whatever thing we have done has been followed. Okay, go till here. Select this contact and metal oxide. Copy and just paste it over here. Escape. Sorry. Copy F3 metal, yeah, it should be 1. Should be keep copy and height. Yeah. Copy it downside. Yeah, we have done. Right now it is P plus, okay. It has to be P implanted. Make it P implanted 1 hour. Make this offset to P implanted distance at 0.02. Options. Make it 0.02. Height. Yeah, done. Yes. Okay. So save and run the DRC. Yes. It's a bit laggy. Yeah. As you can see right now, that floating error, whatever we were looking, whatever we were seeing, P subtrade, the error we were seeing that is disappeared from right now. Next error, they have given annual to P plus oxide species should be 0.3. Where it is 0.3, yeah, it should be 0.3. Select this entire, okay, it should be 0.3. Okay. Options, take it 0.3. Height, yeah, done. Next thing, poly to oxide spacing must be 0.1. Yeah, should be 0.1. Poly to oxide spacing must be 0.1. Just make it 0.1. Okay. First, we are supposed to keep your height as minimum as possible, and you can go on increasing your width, but you are supposed to keep your height as minimum as possible. Let's make it 0.1. 0.1 only, right? Yeah, 0.1 height. That's one. Yeah. We'll see whether it is throwing in a DRC error or not. That we are supposed to save, yeah, on the DRC again. Yes. Next, yes. Again, it is showing that the annual to P plus oxide spacing must be 0.3 micrometer. Now, from the annual, it is showing it should be of 0.3. It's 0.3 only better. Because while doing any CMOS design, you will not face this issue because this is going to lie beneath of your earmuffs. Okay, yeah, done. Next thing, yeah, all the errors we got. Just save and again run the DRC. P implant to P implant spacing must be 0.124. P implant, P implant. Yeah, it should be 0.24. For that, it should be 0.24. Just keep both tab at 0.24 distance only. Over here, make it 0.24. It's done. Okay, hopefully we are not supposed to see any error further, but we'll see. If any arises, we are supposed to resolve it. So this is the analog layout design engineer used to do. They used to keep on debugging the errors that arises while doing the layout. So yeah, we have got rid of this all errors. Next thing, it's a error metal to contact approximately. It is saying that your all the contacts you have designed right till now. It has to be covered with metal, okay? So let's do it, guys. Let's select the metal, click press P and just draw the metal path. P is used for path drawing, okay? Just draw it till here, but this is going to act as a source. Sorry, go till here, the center, okay? Done. Same thing, you are supposed to connect your drain with your VSS. Okay. It has to be enclosed with your contacts. Okay. Escape. Select your path, contact path, and make aligned with your contact stage. Okay. It is aligned. Select your path, make it aligned. Yeah, it is aligned. Escape. Right now it is done. Next thing, hopefully DRC has to clear. Yeah. So we have got the no DRC error found. So it means our DRC is clean. Next thing, we are supposed to run our LVS. LVS drive like layout versus schematic. It is going to compare your schematic with your whatever layout you have designed till now. Okay. So for that, go to Assura, run our LVS. So as you can see, which library we are going to compare with which library cell. Okay. So library, the schematic, and same cell of layout is going to compare. Okay. Next, GPDK90 library technology we have been using. So apply. Okay. Okay. It is running. We have got here some errors. One cell had found pin mismatch. Okay. Okay. So that will be a sticker. Here we have got pin mismatch. Click on it. Yeah, three pins mismatch because we have not created any pins. That's why the it is showing error. Okay. So as you can see, it is saying that in your schematic you are having VDD, VSS and here, but here you have not given any name in your layout. Okay. For that, let's go to our layout. Let's make the pins. Okay. Select pins, make it caps, VDD, VSS and it. Okay. Display terminal name. Check this display terminal name options. Make the height is of 0.06 micrometer. Select this bar. It should be of metal one layout, all label, okay? Because whatever labeling, whatever the layer you are going to draw, the same layer has to be selected over here. Then only it will fit. Next side, okay. So VDD, VSS and A we have given. So it has to be VDD. Just click on here and drag like this. Okay, done. And place your VDD over here. As you can see, this whatever the plus symbol you are going to see, that has to be reside on your metal, because beneath of it you are supposed to see the metal. Then only it will match with your VDD. Next thing, VSS. Here also we have used the metal. VSS, VSS. Next thing is A. Okay, we have not given here E gate. For that we are supposed to extend our poly. Okay, the gate input has to be given to the A input has to be given to the gate, right? Gate terminal, but we have not left here gate terminal. For that we are supposed to extend our poly little bit, because this is going to act as a gate, and on the poly we are supposed to give our gate contact, right? For that, just stretch all of this little bit downwards. Okay, done. And or else we can make gate contact over here. We'll see this metal one R. Okay, done. Keep your contacts from it. Okay, copy your contacts with a bit of word. Done. Move it. Escape. Should be enclosed. Okay. We'll be looking into it. What's the spacing from this edge to the contact edge? For that we have to run our DRC. That Assura, run DRC. Okay, apply. Okay, yes, yes. Okay, that's given contact to offside spacing must be 0.12. You see, yeah, it has to be 0.12. It means we have to stretch this entire thing a little bit downward. Okay, make it 0.12. Yeah, it's track. Next thing, we have to if you resolve one issue, it will ultimately resolve many issues at background. Firstly, you are supposed to see what is due to what I am facing issue. Next error is poly to contact enclosure must be 0.04. You see, poly to contact. I mean, so poly to contact enclosure must be 0.04. Right? It should be 0.04. Stretch or poly. Put outside. Make it 0.04. Space. Yeah, it is done. Next thing, yeah, poly to contact enclosure on at least two opposite sides must be 0.06. Saying that at least two opposite sides means this side and whatever contacts we are going to draw over here, this side enclosure must be 0.06. Okay, make it 0.06 A, observe 0.06. Yeah, it's spaced at distance 0.06. Just copy this F3 and check this. Okay, section 0 step. Make column 5 just supply. Okay, so we have got our contact. Extra contact delete. Just align this metal with your poly. Yeah, align. See what is the space in between this. It should be 0.06, but it is not satisfying. But we will see whether it is run DRC or not, pass DRC or not. Run DRC apply. Hopefully it has to pass. We'll see if any error face, we'll resolve that again. Again it has given poly to contact enclosure must be 0.06. It is poly to contact. Better we will be keeping this 3 contacts. Okay, just delete this. Stretches. Okay. Select this entire thing and keep it at middle. Yeah, what the spacing it was? It was 0.06, right? Over here, user spacing, make it 0.06. Done. Save and run the DRC again. Yeah, no DRC is we can see. Next thing we are supposed to see what's the spacing between this or polyester or P-tab. Okay, just stretch this upward. Yeah, run. You see, run, save and run the DRC. Sorry, it's LVS in progress. Now to run the LVS, we are supposed to run the DRC. We got DRC green, that's why the window closed. Assura, run DRC, apply. Yes. Whatever the maximum spacing it will give, that is we are going to follow right now. It is general 53 means, yeah, the implant to the implant spacing, so it will be 0.24. The spacing we are going to follow. Then all errors will be resolved. Make it 0.24. Select this, make it 0.24. Options, make it 0.24. Done. Save and run the DRC again. Yeah, now it is clean. Okay, the optimal layout design we have done till now. Okay, but we'll see what this spacing is. 0.04. Yeah, done. Okay. Next thing we are supposed to give a pin. Okay, E pin we have not given last time. Yeah, it's 0.6. Yeah, it should be metal one level. It is metal one level. Okay, height. So A. Okay. Yeah. See. Now, right now we are supposed to move our origin at mid of this P tab. For that, go to edit, move advance, move origin, keep it at center. Sorry, it is not centered. Go to edit again, advance, move origin, keep it at center. Yeah, it's centered right now. Next thing, we are supposed to draw the PR frontage. Okay. For that, create PR object, PR boundary. PR boundary should cover your entire theme. Okay. For that, better you just cover this entire thing with PR boundary. Now, make align this PR boundary with your angle. No spacing. Okay. Yeah. So right now our design is almost clear, but we have to again move our origin to our PR boundary edge. Edit, advance, move origin, done, escape. Yeah. Next thing you are going to save and run the LVS. Run LVS, apply. Yeah, it is passed by LVS and DRC. So this is a window we have been seen. It is showing that 0 cell have 0 mole form. It means our schematic and layout is matched. Okay, this is all about the PMOS layout, guys. If you feel any doubt regarding this, you just put your message in comment section. We will happy to help you out. So that's all, guys, for today. So we'll see in next video. Till that, okay, bye. Thank you for watching this video.